Hey, welcome to lesson number 2. Hopefully you tried the first sprint and you have all the answers there. Go ahead and pause this video right now and check your answers against mine, and then I'm going to start talking about a few of them. So you're pausing. I'm going to wait a few seconds. All right, so hopefully you just finished checking your answers against mine because you had already done this yesterday or before this video or whatever. Let's talk about how I got some of these answers. So the first few are really easy because they're just a number divided by 100. But divided by 100 literally means the exact same thing as the percent sign. So if you have a number over 100 or divided by 100, then it's just that number percent. Like dividing by 100 and the percent sign are interchangeable. They mean the exact same thing. Now, on some of these fraction ones here that I wanted to turn into a percent that where the denominator was not 100, what I'm doing in my head is I'm using a proportional relationship or equivalent ratios to change the denominator to 100, and then the number on top becomes my percent. So for example, number 9 is 1/10, and so I'm thinking, okay, well if I want this to be out of 100, I just multiply top and bottom by 10, and I get 10 100ths, and so that's where I get 10%. And so I did the same thing with 2/10 and 4/10. With the ones where they give you a percent and they want you to write it as a decimal, I'm just thinking about where that decimal point would be and moving it over 2 spaces to the left. So 75 becomes 0.75, 10 becomes 0.10, 5 shouldn't become 0.5. If you move the decimal place 2 spots, 1, 2, you create that extra spot for that 0, and you should get 0.05. In other words, 5% is 500ths, and so that 5 needs to wind up in the 100th spot, not the 10th spot in your answer. Some of the more trickier ones were over here in the second column. Let's see here. Yeah, when you get here to where you got 9/75ths, so there's a couple ways you could do this. You want to get this as something over 100, right? Well, one way you could do it is by thinking, okay, if I want to change 75 to 100, I need to add an additional 25, and 25 is 1/3 of 75. So if I multiply the bottom by 1 1/3, I get 100. And so if I multiply the top by 1 1/3, a third of 9 is 3, so I get 12 over 100. That way is kind of tricky for a lot of people, though, to think of like, oh, I want to add an extra third to 75. That's weird for a lot of people. So another way to do it, let me see if this is on the screen, let me pull down a little bit, is to find a number that is easy to make 100 out of. So for example, if this is 9/75ths, well, 75 is hard to turn into 100 using multiplication, but I know that 25 is easy. I can change this to 3/25ths by dividing top and bottom by 3. Now it's really easy to multiply top and bottom by 4 and get 12 100ths. I think that's the strategy that most people like. So, and then from there I used a pattern. I didn't have to do that again for 18/75ths and 13/75ths because I know that 18 is double 9, so I should have double the percent, and 36 is double 18, so I should have double 24%. I get 48. These were, just a simplification. 96% as a fraction is 96 over 100, and if you simplify that correctly, you get 24/25ths. But then I noticed that, that means that since I'm 4% away from 100, and I'm 1/25th away from a whole here, then every 4% is the same as 1/25th. So the next question, I lost 4%, so I lose 1/25th. And then the next question, I lost another 4%, so that means my fraction must go down by another 25th. So I was using those relationships. And then down here at the end, I don't know if you guys remember this, but we did a Kahoot one time about converting decimals. And I said that the best thing you could sort of learn or memorize from that Kahoot was that all the ninths fractions have this weird thing where 1/9 is equal to 0.1 repeating, and 2/9 is equal to 0.2 repeating. So I should have the repeater bar over this 2. And 8/9 is equal to 0.8 repeating. And so because I just remember that fact, I was able to quickly say that 1/9 is 11.1 repeating percent, 2/9 is 22.2 repeating percent, etc. So that was convenient facts for me to have memorized. All right, that's all we're going to do in the book for now, I want to look at this worksheet I would have handed out in class today if we were in the classroom. And it's sort of like a primer or something that's meant to sort of like get you ready for the three different types of percent problems that the book likes to focus on. In all these percent problems, you essentially have three pieces to the problem. You have a part of something, you have a whole that you're taking a part out of, and you have the percent that represents how big that part is. And essentially the three types of questions they like to give you in the book is they tell you, you have this whole and you have a part that's this big out of it, so what percent is that? Or they might say, okay, you have this whole thing and you're going to take this percent out of it, so how big of a part do you get? Or they might say, well, you have this part of something and you know it represents this much percent of it, so how big must have the whole been that it came out of? In other words, there's these three pieces. They always give you two of the pieces, and you just have to find the third. And as long as you're able to identify which two pieces they gave you, then just remember the strategy for finding the third piece when you know what type of problem you're dealing with. There's a couple different ways people like to do it. You could sort of just memorize some methods, which is a perfectly fine way of doing it. You could also rely on the algebra that we learned in Module 3, and that's sort of the strategy that I'm going to rely on the most, just because I feel like if we spent all that time getting really good at algebra for like 3 months, we might as well use it. So it says here, the first type of percent problem is when you are given the whole and a percent, and you're asked to find the part. So for example, you might get asked, what is 15% of 60? And so I've identified like what's going on in this question here. This is a question where they tell you the whole is 60, the percent is 15, and you're trying to figure out how big this part is. When you're reading these word questions, one tip to always remember, if you're trying to figure out like what's the whole and what's the part, the percent is usually easy to figure out which it is because it literally has a percent sign from it. But sometimes it could be hard to figure out, wait, this other number that's in the question, is that the part or the whole? Well, the thing that we consider the whole, I'm going to say always, but watch there be one case where this isn't true. So I'm going to say quotations always comes after the word of. Right? Because you're taking I was a little off the screen there. You're taking a percent of something that's the whole. And so when you're reading it, whatever number follows the word of is almost certainly the whole in consideration of that for that question. So our job here is to find the part. What part is 15% of 60? Well, just as the word per can be thought of as divided by, the word of in mathematics can be seen as multiplied by. In other words, just like at the beginning of the school year, I said, hey, every time you see per, let's think of that as division. Every time we see the word of, let's think of that as multiplication, right? Like if you have 3 of something that has, 3 of something in it, like a 3-pack of something, and you want to know how many you have total, you're going to wind up doing 3 times 3 to find out that you have 9 of them, right? So the word of almost always implies, hey, let's multiply. The last thing I want you to remember is that the word is just mathematical speak for an equal sign, right? If something is something, then it equals that thing. And so I'm reading this as what equals 15% times 60, right? Where it says is, I thought of as equals, and where it says of, I thought of as multiplication. And that could be translated, like taking that sentence could literally translate to, okay, well, where it says what, I'm just going to use a variable. I don't know what is. So something, x, is, so that's equals 15%. Now I'm not going to write 15% because we don't do math with percents. We always have to convert them to a decimal or a fraction first, or else our answer will come out 100 times bigger than it should. So I'm going to write 15% as 0.15, and then of means times, and then 60. And so all I have to do is 0.15 times 60, and I'll figure out what x is, the part in this case. And that's the same thing I have written down here, except I have the answer. The answer is 9. 0.15 times 60 equals 9. So I'm going to do A here real quick, just to show you one more time how this works. And then you do B. You pause the video for a second and do B. So what is 30% of 60? Well, what, that's like the unknown, so I'll put an X there for that, is means equals 30%, that's 0.30, but I'll just write it as 0.3, of, that means times 90. So I'll figure out my unknown, or my part in this case, if I just do 0.3 times 90. And I could do this in my head, but I want you guys to just see the whole process. So 0.3 times 90 equals, oh, I must have messed up. 0.3 times 90 equals 27. So 27 is 30% of 90. All right, you try to do question B real quick. So you're pausing the video, doing that real quick, and then you're going to unpause it, and you're going to see me do this as soon as you unpause. All right, so I'm continuing, assuming you paused and did it. So what, that's my unknown, is, that means equals 125%. If I move the decimal 2 spots, 1, 2, that's 1.25 of, so that means times 240. Your answer should have came out bigger than 240 in this case, which is an important thing that we should talk about. So let's see here. I'm going to do this one in my head. 1 times 240 is 240, and then 0.25, that's the same as a fourth. So a fourth of 240 is 60. 60 plus 240 equals 300. So you should have got 300. And now hopefully you're asking yourself, wait, that doesn't make any sense, because I'm supposed to be finding the part of something. How can 300 be a part when 240 is the whole? That's totally okay. That's allowed to happen. Sometimes the part is bigger than the whole. Sometimes we want to find parts of things that are more than 100%, and then they wind up bigger than the whole. And that seems weird, but it's totally okay. All right, so don't always automatically assume that the part is supposed to be smaller just because part sort of seems like a word that should be smaller than whole. All right, the second type of percent problem, so I'm reading here now, is when you are given the part and the whole and asked to find the percent. So for example, what percent of 80 is 12? Okay, so notice that the word 80 comes after the word of, so that means in this case it's the whole, and I have a part that's 12 out of 80, and I just want to figure out what percent of that is. So one way you could do this question is just by translating this sentence into an algebraic equation. What percent, so that's an unknown, so I don't know what that is, so I'll just make that x, of 80, so times 80. I could write x times 80, but we're not supposed to do that. We're always supposed to put the number in front. So 80x equals 12. And then to solve this, I just want to divide both sides by 80, right? And I get x equals 12 over 80, which, well, let's do that on the calculator real quick. 12 divided by 80 equals 0.15. But we're not done, because it asked me what percent, and this is a decimal. And so if I wanted to answer in percent, I would need to convert this to a percent, which is 15%. And some people don't like to do it that way because they're like, wait, why do I have to convert at the end? I'd rather just have the math done properly the first time. And so another way you could do this question is right here. You could just set up the fraction 12 divided by 80 because you understand, okay, I have a part of 12 and a whole of 80. So I have this ratio of parts, right? 12 to 80. And to find a percent, I want to turn that into a ratio out of 100 because that's what percents are. Well, if you multiply 80 times 1.25, you get 100. So you have to multiply the top also by 1.25 and you get 15. This x right here, this is supposed to be a multiplication x. This is not a variable. This is the multiplication x. I shouldn't have used it. I shouldn't use that x because you might be looking at that going, wait, 12 80th x, what? So just wanted to clarify that. So in this way you would get 15 out of 100, which we know is the same, was also 15%. So in other words, if you're given the whole and the part, just take the part and divide it by the whole and you'll get the decimal version of the percent, and then you got to convert. All right, so let me do another one for you real quick. What percent of 50 is 37? I could set up an algebraic equation like this one, like I did up here, or I could just say, hey, I know that if I have a part and a whole, I go part divided by whole, and I just divide them, so 37 divided by 50, and I get 0.74, but I'm not done, because that's a decimal, and they're asking me for a percent, so I have to convert that to 74%. All right, you try B right here. What percent of 60 is 39? Before you start, I want you to get in the habit of estimating your answer before you start. So you should know that you're going to get an answer a little bit bigger than 50%, because 30 is half of 60, that'd be 50%. But this is 39. So I'm thinking, okay, it's going to be more than 50%, but probably not like up to 75 or 80%. So you should be looking for an answer somewhere in that range. And if you get something outside that range, then that should trigger your brain to say, hey, wait, this answer doesn't make sense. All right, so pause, do this one real quick, and then I'll continue. All right, so hopefully you paused and you did 39/60ths, and you could just divide that out with your calculator. 39 divided by 60. So you get 0.65, which is 65%, which is like in that range that I was talking about where the answer should be. All right, then the last type of question is probably the weirdest one, the one that people find the hardest, is where they give you a part of something and they tell you what percent it is of some whole, and it's your job to find the whole. The way you find the answer to this one is you wind up dividing the part by the percent, which for a lot of people feels really weird. But if you think about it, it's just the inverse of the other type of question, where when we had the whole in the percent, we multiplied. And this time where we get the part in the percent, it's like we're undoing that operation and we want to divide to get back to the whole. So let me take this statement here and turn it into an algebraic equation using the fact that is an equal sign and of is multiply. So it says 180 is, so that's 180 equals 90%, I'll write that as 0.9, of what number? So of means to multiply, and then what number, that's the thing I'm trying to find, so I'm going to use a variable. So the equation winds up being 180 equals 0.9x. And I actually have that written right here. I just wanted to write it separately so you'd see me like build it, you know? And so in order to solve this equation, I just wind up dividing both sides by 0.9, which is the percent. And the answer winds up bigger than 180, which makes sense, right? Because if 180 is only 90% of the number we're trying to find, then the number we're trying to find should wind up being bigger than 180. Anytime you divide a number by a decimal that is smaller than 1, but it's still positive, like it's not negative, then the answer is going to wind up bigger than the number you started off with. So kind of get used to that. All right, so the answer to this one was the whole in this case would be 200. So let me do this one for you. 90 is 20% of what number? I know 20% is 1/5. So they're asking me 90 is 1/5 of some number. I know that's going to be in like the 400 to 500 range. So if I get something outside of that range, that means I probably messed something up. So let me just take this statement and turn it into an algebraic equation. 90 is, that means equals, 20%, I'll write that as 0.2 of, that means times, and then what number, I'll just use a variable to represent that. And then I just want to solve this by dividing both sides by 0.2. So I get 90 divided by 0.2 equals x. And this is going to give me a big number, way bigger than 90. I think it's 450. 90 divided by 0.2 equals, yep, 450 is the whole in this case. So x equals 450. All right, you try that last one. 12 is 75% of what number? So go ahead and pause it, and then I'll show you the answer in a second. All right, so hopefully you paused and you worked this one out on your own, and you should have written something like 12 equals 0.75 times some unknown number that we're trying to find. and then you divide both sides by that 0.75, and you should get something bigger than 12. 12 divided by 0.75 is 16. So x, or the whole in this case, equals 16. All right. I want to show you one last thing real quick before we end this video. I'm going to go back to lesson 1. So we're still kind of trying to get good at converting from fraction to decimal and decimal to fraction and stuff. So this is the exit ticket for lesson 1, and it's more of this just converting decimal to percent and to fraction, etc. stuff. It says, I'm going to skip this one because we actually did this one in the classwork already. If I want to change 1.125 to a percent, I just move the decimal point over 2 spots to the right, and I get 112.5%. And if I want to write this as a fraction, well, I could write it as 112.5 over 100, right? Because that's what this percent sign means, divide by 100. But then I don't want to have this 0.5 up here, so in order to move the decimal one more spot to make a whole number, I'll multiply by 10 on top, but I also have to do it on the bottom, and I get 1,125 over 1,000. And then you'd have to simplify this one by dividing by 5 on top and bottom and all that stuff, but we're not doing that right now. The main reason I wanted to go to this page, though, is to look at 2/5%. When you're trying to take a fraction percent and turn it into a decimal or just a normal fraction, I think the easiest thing to do is to first convert it to a decimal percent. So 2/5, that's the same as 4/10, right? Which is the same as 0.4. So I'm thinking of this as 0.4%. Now it's really easy for me to move the decimal point over 2 spots, 1, 2. So I put a 0 here and a 0 here. This is equal to 0.004. So this is really small. This is 2/5 of a singular percent. And then lastly, if you want to change 2/5% to just a regular fraction, well, this is 2/5 divided by 100. That's what 2/5% mean, because percent means divided by 100. Well, if we want to divide something by 100, if we think of keep, change, flip, that's the same as multiplying by 1 over 100, and we get 2 over 500. In other words, when you want to change one of these fraction percents into just a regular fraction, you can just take that denominator and make it 100 times bigger, or multiply it by 100, and you'll have your actual fraction. All right, that's it for today.